Hi everyone, I am Mrs. Xie. Welcome to my math video. Today I am going to show you how to factor the polynomials. We have learned factoring of the numbers in previous video about the number. Factoring is a very useful way to make calculations simplified. As you probably have learned in algebra, expressions can be simplified from factoring out the common factors too. The same concept exists in polynomials when we need to find out the roots of the polynomials. One way is to factor the polynomials. Let's start. In today's lesson, I will review what is polynomial, degree of the polynomial. We will start with the factoring by finding the greatest common factors of all terms in the polynomials. There are many other ways to start the factoring process, such as factoring by grouping, factoring by finding the patterns by substitution, or factoring by using zeros found. Let's start by learning factoring out greatest common factors of all terms. Then we expand the factoring to more common types of factoring problems such as factoring trinomials, in which we will go deeper to explain the steps and methods applied. Last, we introduce special cases and formulas for factoring higher degree polynomials. In previous lesson, we have learned how to do prime factorization of a number. In fact, so if there are two numbers, you will list all the factors of the two numbers and find out the greatest common factors of the two numbers. This is called GCF in math. Similarly, there is a need to factor all common factors in algebraic expressions. Algebraic expressions are a combination of variables and constants joined together by using operations such as addition, subtraction, multiplication or division, exponentiation. Why is it so important to factor the expressions? Because it can simplify the expressions. In future, when you learn zeros of the equation, you will understand the factoring helps in equation solving too. The polynomials are just the sum of a finite number of monomial expressions called term of the polynomial. Each term is an algebraic expression. Even a constant can be a term in polynomial. The polynomial has a concept called degree. Since polynomials are made up of finite terms, each term has its own variables. The addition of all variables' exponent numbers in that specific term define its own degree. The highest degree of all terms define the polynomial's degree. For example, a second-degree polynomial with one variable x can be written as f of x equals a times x squared plus bx plus c. An equation of this form is called quadratic function. To review how to do GCF, let's start with prime factorization. A prime factorization of a positive integer number is to find all factors of the number whose factors are prime numbers. A prime number is the number which has only two factors, one in itself. For example, 30 can be factorized into 2 times 3 times 5 using prime factorization method as shown. 2, 3 and 5 are prime numbers that cannot be factored again. Now we know how to do prime factorization of a number and find out the greatest common factors of the two numbers. Similarly, there is a need to factor all common factors in algebraic expressions. Algebraic expressions are a combination of variables and constants joined together by using operations such as addition, subtraction, multiplication or division, exponents. For example, 18xy is an algebraic expression, 12 times y squares times x is another algebraic expression. To get the GCF of the two expressions, first we will find the GCF of the coefficients of the two expressions, then we look for common variables and the greatest common exponent of the variable, combining the numbers with the variables to get the GCF of two expressions. Let's go over an example. It's useful to factor the greatest common factor first. For example, in this polynomial, 18x to the third power times y to the sixth power times z plus 42 times x squares times y to the seventh power times z squares plus 30 times x to the eighth power times z to the fifth power. As you observe, the coefficient numbers 18, 42 and 30 are all even numbers. Immediately you sense there is common factors for these three numbers. To be more specific, you can use GCF method to find the largest common factors of all coefficients. Next, you can apply the same method to variables x, y and z. At the end of the exercise, you can derive the GCF of the polynomial by finding GCF of variables and coefficients. A common problem in algebra is the factoring of a trinomial that looks like this. The coefficient of x squares is 1. The general form for this case is x plus p, x plus q, equals x squares plus the sum of p plus q, times x plus a constant which is p times q. How to factor this polynomial? We can use trial and error method. Since the coefficient of x squares is 1, all we need is to find two numbers. The sum of 2 is equal to the coefficient of x and the product of 2 is equal to the constant. To find two numbers, we xn the sign of x and constant term. In this case, the constant term is positive and the x term has negative coefficient, which means the two numbers have to be negative. By trying different factors of 8, we conclude -2 and -4 are the p and q value for the question. When coefficient of x square is not 1, one way to factor trinomial is to use AC method. The key of AC method is to find two numbers that satisfy the condition in step 2. Then split the middle term and use grouping to combine the common term to finish the factoring. Another way to factor trinomial is to use butterfly method and cross-multiplying the factors of a and c to get two intermediate products. The goal is to sum the two products to match the middle term. The quadratic formula is designed specifically to find roots of a second-degree equation. However, it can also be used to factor second-degree polynomial f, x, equals x squared plus bx plus c. What are the special forms of polynomials? Two of the common ones are sum and subtraction of perfect squares and perfect cubes. Whenever there's a pattern like these, you can factor them using the formulas. As you can see from the two examples on the right side, by applying the appropriate formula, when the coefficients on the variables are cubes or squares and the exponents on the variables are multiples of 2 or 3, the polynomial is factorized. Thank you for watching my video. See you next time.